Hello students, we are starting today the next unit, solutions. Actually solution is a mixture of two or more components, is it? And the components may exist in different physical state like liquid, solid and gases. Now let us see the introduction of this lesson. So you just all know about the mixtures. When the substances are mixed together, solid or liquid or gases, then simply it is called as a mixture, is it? Now the examples are air. Air is a mixture of different gases, and rock is a mixture also, and body fluid is also a mixture. Sugar solution, sugar when it is mixed with water is a solution, and then tea is also example of solution. Aqueous salt solution is also the example of mixture, is it? Now further mixtures are classified as homogeneous and heterogeneous depending upon their appearance. Homogeneous mixtures are those mixtures in which the components are uniformly mixed together, is it? And heterogeneous mixtures are those mixtures in which the components are not uniformly mixed, is it? The next is, let us say about the homogeneous mixture. Now homogeneous mixture, there is the uniform mixing of the components of the mixture. Here, depending upon the size of constituent particles, these homogeneous mixtures are again classified into two categories, that is true solutions and colloids. Okay. Now we are focusing about the true solutions, is it? Now solution. What is a solution? Definition of solution is, solution is a homogeneous mixture of two or more pure substances where they are mixed uniformly, is it? Now true solution consists of solvent and one or more solutes. For the formation of solution where there is a homogeneous mixture of the components, the one component which is present in the larger proportion is called as a solvent, and the lesser proportion is called as a solute. But here solute, one or more solute may be present in the solution. Okay. Now here in this lesson we are focusing on binary true solutions. What is binary? The word binary is for two components. A solution which is formed by purely two components is called as a binary solution. Now see here, types of solutions. Here the next point is type of solution. See here, solvent and solute may exist in three physical states, that is solid, liquid and gases. Say the solvent and solutes, the components of the solution may exist in three physical states, solid, liquid, gases. Depending upon these three states of the solute and the solvent, they exist. The combination of three states as solute and solvent gives rise to 9 types of solutions. Okay, and for these 9 types of solutions, if you just refer the table number 21 in the textbook on page number 28, here I will show you. Here this table, here depending upon the this different physical state of solute and solvent, different solutions are 9 types of the solutions can be formed, is it? Here I will just give say states of nature, that is solute and solvent, the state, physical state. Solid, if in the three cases, let us see the different types of the solution, that is 9 types of the solution, when the states of solute and solvent changes. Now this is the column for the physical state of solute and this is the column for the physical state of solvent. The solid, when solid is a solute and solvent as a liquid, you can just call it as solid in liquid, solid in liquid. The example is seawater, where the salt is dissolved in water. The next type of solution is solid in solid, metal alloys such as brass, bronze, iodine. Solid in gas, the example is iodine in water, air, iodine in air. The next is when the solute is taken as a liquid everywhere in three types: solid in liquid solvent, solid solute in liquid solvent, gasoline, ethanol in water. Liquid solid, amalgam of mercury with metal as mercury in silver. Liquid solute in gas solvent, chloroform in nitrogen. The next category, by changing the states in the three next examples of the solute: the gas solute in liquid solvent, carbonated water, CO2 in water, oxygen in water. Next example, gas as a solute and solid is a solvent, hydrogen H2 in palladium. Gas as a solute and gas as well, the solvent, air. Okay, air is the best example, that is the mixture of different gases. Okay, so these are the 9 types of the solution can be formed by changing the state of solute and solvent. Is it? Let us see the next point, that is the capacity of a solution to dissolve solute. The capacity of a solution to dissolve solute. What is solution? It is the mixture of homogeneous mixture of the two components here. Now solute, the component which is present in the lesser proportion. Let us say the capacity of a solution to dissolve solute. Let us say let a solute is added to a solvent. Now here what we are doing, a solute like salt or sugar we are adding in a solvent like water. Okay, what happens while adding? It gets dissolved slowly. Initially it dissolves radially, that means the dissolution is rapidly takes place initially. Okay, after some time, if we add more and more amount to dissolve in a particular solvent, at a particular stage the dissolution stops. That means the amount still remains at the bottom of the solution. The amount of the solute starts to remain left at the bottom of the solution. See, that solution now it is called as a saturated solution. So what is saturated solution? The solution which contains the maximum amount of the solute in a given or a specific amount of the solvent. The saturated solution formation takes place finally. Now at this stage a dynamic equilibrium is reached. A dynamic equilibrium is reached. And what is the dynamic equilibrium called here? Here at this stage the number of particles of the salt passing into the solution are equal to the number of molecules returning from the solution towards the salt. So these two processes becomes equal, is it? Now see here, we can represent all these here: solute like salt or any sugar, solvent like water. This is the mixing process or dissolution. That means towards the right forward direction it is the dissolution of the salt in water or solute in solvent, and in the reversible order it is the crystallization, is it? So this is the forward process, that is the number of molecules passing into the solution and the number of molecules returning from the solution. This happens because of the dynamic equilibrium at the saturated solution point. Now saturated solution contains maximum amount of the solute dissolved in a given or the specific amount of the solvent at a given temperature. This temperature factor is important. Now after the supersaturated solution, we have seen about the saturated solution. Now what are the supersaturated solution which are unstable? Say the excess amount of the solute present than the amount which is required to establish the equilibrium in the solution, dynamic equilibrium in the solution. That is called as the supersaturated solution, and this type of the solutions are unstable and being these are unstable, if we try to add a tiny particle of the crystal, then the precipitation occurs. Is it? So this is about the capacity of the solution to dissolve in solute. Okay, that means we have here seen saturated solution, the formation of saturated solution, establishment of the equilibrium, where these two molecules passing in the solution and coming out from the solutions become, the processes are becomes equal. Now see, this is the representation of the dissolution where the equilibrium is established. Okay, let us see the next point. Now see the next point, solubility. Solubility is expressed in moles per liter. Is it? Now how the solubility is defined? This is the amount of the solute per unit volume of the saturated solution at a given temperature is called as solubility of a solute. Is it? Here temperature factor is important and the word saturated solution. The amount of the solute per unit volume of the saturated solution at given temperature is called as its solubility of a solute. The solubility of a solute is its maximum concentration and expressed in the concentration unit as moles per liter. Is it? Now see here, factors affecting. Let us say what is solubility actually. That is the maximum amount present in a specific amount of the solvent. Instead of saying maximum amount of the solute, we can simply add here word as a saturated solution. Is it? So it is the amount of the solute per unit volume of the saturated at a given temperature is called as solubility. But the how much amount of the solute is present in a solution or a saturated solution depends upon some factors. Okay, some factors affects the dissolution or the process of solubility of a solute in a particular solvent, as nature of solute and solvent, temperature and pressure. These three factors affects the solubility of a solute. Is it? We will see these factors in the next session.